Hey everyone, it's Mrs. Trahan-Martins, and today I'm going to elaborate on the difference between lateral area and surface area. So I thought today I would start with prisms and cylinders, and I can make another video on pyramids and cones if you need it. So the first thing you need to know about a prism is that a prism is a three-dimensional shape where you have all polygon faces, and two of the faces are going to be the same polygon. So for example, this red prism over here is a triangular prism. This is a cube. It might be a rectangular prism depending if these sides are longer than the cube itself, the square in the front I mean. This is a pentagonal prism. This is a hexagonal prism, octagonal prism because it has 8 sides, and I don't know how many sides this one has, but whatever it is some kind of prism with these two polygons. The second thing you need to know is that we actually measure the distance of the height between the two bases of the faces that are the same. So in this pentagonal prism, even though it looks like it's sitting on this base, and so you would think this would be the height, but we define the height, like I said, as the distance between the two bases, and so this would actually be the height of this pentagonal prism. I don't know why that arrow didn't stay. So if I'm thinking about a prism, then I have my two bases, and so if I look at this triangular prism, I've made the net over here. So I know, since it has two triangles, that the base is a triangle, and so I have two of those. And so my other faces are called lateral faces, so lateral meaning side. So these are the faces that are wrapping around my prism here. So if I think about this net and the way it's folded up, this here represents the height or the distance between the bases. So this is the height of my prism, and these are the two bases. And these three rectangles, and they're three because it's a triangle. If it was a pentagon, they would have 5 rectangles. Then these rectangles here represent my lateral faces. And so when I'm finding the lateral area, I only want to find the area of these lateral faces. In other words, I want to know what the area of this rectangle is altogether. Okay, well, I already know the height, and I know that the area of a rectangle is base times height. Well, that means I need to figure out how long this side is. But let's think about that for a second. This side wraps around the triangle. And so what I'm really finding here is that the distance, right, this length is the same as this. This length is the same as this side of the triangle, and this length is the same as that side of the triangle. In other words, the length of this side is actually the perimeter of the base. And so the area of this rectangle is perimeter of the base times the height. So if I wanted to find the lateral area of any prism, I need to find the perimeter of the base and then multiply that by the height of the prism, or the distance between the bases. When it comes to surface area, that is the total area of all surfaces of the prism, which means I need to add on the two bases that I previously did not find the area for, which is why my formula says lateral area plus 2 times capital B, where capital B stands for the area of the base. So if I'm thinking about a triangular prism, then I need to find the area of the triangle, which means I need to know the base and I need to know the height. Now once I know those things, then I can find the area of one triangle and multiply that by 2, and I have found the surface area of my prism. So in general, the lateral area of any shape, any three-dimensional shape, is the area of the lateral faces, and the surface area is the total area, so lateral faces plus the bases, okay? So if I'm thinking about perhaps a cylinder, even though a cylinder is not a prism, it still has two bases and it has a lateral face. So the two bases are circles, so they're over here on the net, and its lateral face is still a rectangle, very much like the prism. So if I want to find the lateral area of a prism, then I need to know the area of this rectangle. And so I'm going to show you how it is actually the same formula as prism, even though you'll see it written as LA equals 2 pi RH. So let's write that down. LA, bear with me, equals 2 pi, ooh, look at that too, 2 pi RH. Now, we know what the H stands for. H stands for height, right? Or the height of the cylinder. Here's the height of the cylinder. Now, when I open up the net, you got to think about this as like, I don't know, a can of soup, right? You pop open the top, maybe you pop open the bottom, I don't know why. But here's the height of the cylinder. So that means I need to figure out what this distance is from here to here. But again, let's think about that. This distance from here to here needs to be able to wrap around the circle, which means it's the perimeter of the circle, which we call circumference. And the circumference of a circle can be found using the formula 2 pi r. So the area of this rectangle, or the lateral face, is 2 pi r times h, which is where we get this formula, 2 pi rh. Now, very similar to the prism, you want to add on the two bases to find the area of the total surface, or surface area. So if I already know that lateral area is 2 pi rh, then I know surface area is going to be lateral area plus 2 times the area of the base. But guess what? The base is a circle, and we know that the area of a circle is pi r squared. So I have two bases, and I know the base is a circle, so that's going to be 2 pi r squared. So if you're thinking about a cylinder, lateral area you can think of as the label on a can of soup, and surface area is how much tin you need to make that can. Okay, so once again we have prisms. The perimeter of the base actually represents the length of the rectangle that's created when you open the net, times the height, which is the distance between the two bases, and the bases are the polygons that look the same. And in a cylinder, we have lateral area, which is 2 pi rh, 2 pi r being the circumference around the circle. That's the perimeter, or the distance here from on this rectangle, times its height, 2 pi rh, and surface area you want to add on the two circles, which is 2 times pi r squared. Goodbye.